All right, so every discipline has its own sort of jargon and its own things that it deals with. Okay, I'm not a doctor. I am an architect, so I know that there's something called a scalpel, but I'm guessing that there are lots and lots of other special kinds of knives. All right, and they've got all sorts of other tools and things that doctors might use, right, to do their job. If I was a pilot, there's a whole sort of list of jargon that goes with being a pilot. All right. So one of the things that's important in studying architecture is to learn a little bit about what the media is and what the types of drawings are that architects use to both look at architecture, understand architecture, and communicate architecture. Okay? Does that make sense? And that's not something that you're all going to be familiar with. So for example, if I asked you guys what's a section, right? Some of you might raise your hand and say, oh, it's a part of the stadium where you sit when you go to a concert. But that's not what an architect means by a section. If I asked you what a paraline drawing is and how it differs from a perspective drawing, you guys might not know the difference. You might not have ever even heard the term paraline, or axonometric, or isonometric, or oblique, or any number of different words that architects use for the types of drawings and stuff that they're going to be working with. And it's not just architects. It's any kind of design profession. Engineers, interior designers, landscape architects all use these types of drawings and these types of devices, all right? And they have a similar jargon between the disciplines. All right, so some of the things that we're going to be looking at are going to be things like photographs, perspective drawings, a site plan, a floor plan, and elevation. So these first two things are going to be looking at things as a flattened version of 3D reality. These four, all right, all the way down from site plan, floor plan, elevation, and section, are going to be flattened views of things. After that, the paraline drawing we'll discuss as a 3D drawing, bird's eye view. Can either be a 3D drawing or it can be a photograph. Massing diagrams are something that this particular PowerPoint doesn't do very well. And then there are architectural details, right? And that all depends at the scale at which you're looking at a building in. So let's take a look. So photographs. So one of the things about photographs is that they're taken from one point of view, right? And they're taken usually through some form of a camera that is going to have some barrel distortion to it, depending on the type of lens that it has. But they're basically intended to take snapshots of something from various viewpoints. And it may take many of them to kind of understand the overall complex, right? Or the overall object that you're looking at. This is the parasol that I think is it's in Spain. I forgot what city it's in. It might be Madrid, but I'm not positive. This is when it was under construction. It's all made of wood. It's a big wooden structure, and it's huge. You can see the scale of people here compared to it. But you can tell that that's going to be a hard thing to understand from this image. What does that look like from the sky? I don't know. Right? You can't tell from looking at the image. You can only gather the information that's kind of included there, and part of that information has to be filtered through your ability to perceive three-dimensional form in a flattened two-dimensional image. Okay? So very similar to the photograph is a perspective drawing or rendering. This particular thing, I believe, is a watercolor, okay? And it's a hand-drawn thing that sort of depicts, this big building. I don't know which building that particular one is, but essentially, before there were cameras, right, and before photography became as prevalent as it has become, people used to communicate something via a perspective drawing, right? Architects often will rely on that. Before computers, architects and engineers and designers relied on perspectives to be able to show somebody what it might look like before it was ever in existence. So, Now we get to the flattened views, okay? Or generally we get to the flattened views. So one of the flattened types of drawings that you guys will be encountering is called a site plan, okay? Now, site plans are going to show the buildings, grounds, and geographic land features in relationship to each other. So as compared to looking at just a building, right, the site plan would show the walkways around the building, maybe the trees around the building. It might show how the land is sloping via contour lines. It might show where the lights are around the building. If there's a lake, it would show where the lake is and how close the building is to the lake. Most of these drawings are generally scaled drawings. All right, so the next 4 drawings that we're going to be looking at, the next 4 drawing types that we're going to look at, are usually scaled drawings, and they are either going to have a written scale or they're going to have a graphic scale. Now this one has neither, unfortunately. Or no, it does. There it is, right there. From there to there is 150 meters. So this one has a graphic scale. Other drawings, right, will have a written scale, and they will be printed to an exact size. All right, or a very precise size, so that you can take a scale, lay it on the drawing, and measure a distance and say, oh, well, that's 500 feet, or that's 150 meters. Okay? They are flattened. That is, there's no intention to show 3 dimensions. And with site plans, there's kind of 2 approaches that you can take to it. Okay? One approach is to show what's inside of the buildings on the ground level in relationship to the things that are around it. The second sort of path that you can take with that is to show the roof outlines of the shapes of the buildings in relationship to the same thing. They're going to look very, very different from each other. Okay? And depending on what you're trying to convey, that drawing is going to have meaning one way or the other. If you're trying to see how the forms of the buildings relate to the landscape, you might want to look at the roof drawing with shadows. If you're trying to see how the rooms relate to the landscape, you may want to look at the plan superimposed on the site drawing. Okay? All right. One more thing that's really important is site plans generally always have to have a north arrow. Okay? And this one's backwards from the norm or from the standard. The standard is that north is usually facing up on a drawing. As much as possible, you want north to go up. That's a convention. When somebody that looks at drawings and maps and stuff, when they look at it, they typically expect north to be up. If you go to AAA and you get a map, guess what? North is up. When you start Google Earth or you start Google Maps, north is up. Even when you turn your phone sideways, it kind of rotates and frustrates you, right? And you have to lock the phone and say, I don't want it to turn. God. All right. This is a colored view of the site plan. The previous one sort of showed like the inside components of the building in relationship. This one's showing more of the overall forms of the building with shadows in relationship to it, and it's colored. I'm not positive. This could be the Capitol building, but I'm not sure. I didn't put this PowerPoint together. This PowerPoint was put together by a previous faculty member. The next thing is a floor plan. Okay? And this thing has one description of a floor plan that I kind of take issue with, and that is this 5 to 6 foot. So we'll take a quick look at that. Floor plan shows the relationship of internal elements of a building, so the rooms, walls, columns, windows, etc., okay, in relationship to the other parts of the building. So the primary spaces, according to function, the required adjacencies, all of these things are referred to as circulation. So it shows the relationship of the primary rooms to the circulation spaces. There's a number of things that are covered inside of a floor plan. The way that I try to describe a floor plan is that it is a horizontal slice through the building, but I typically tell students that it's at about 4 feet above the finished floor, right? Slice the building and then look down. The reason I say that, if I walk back to those counters that are back there, right? The cabinet and the counter. In a typical drawing, you would see the lower face of the lower cabinet, okay? And then you would see a dashed line further back that delineates where the cabinets are above. So there's a little dashed line, and that says, hey, this is up higher than the cutting plane. So if we were to use this as the correct height, we'd be showing both of them in section, because 6 feet is cutting about through the middle of those upper cabinets back there. Okay? So my take is it's 4 feet above the finished floor, approximately, sliced through looking down. So right here I have a kind of an explanation of that. So here's a little building, little house or something, right? And you can see that someone went up and they sliced through it, right? And then they removed the roof and they kind of highlighted what you see when you're looking down. This is a three-dimensional drawing. This is not a floor plan. This is a floor plan. The floor plan is a flattened view, okay? It's had all depth removed from it. So there's a door, here's a door. There's a window, there's a window. Here are 1, 2, 3, 4 windows. Here's 1, 2, 3, 4 windows, a door, and another window. Notice that over here we're looking at these things as openings. Here we're looking at them as symbols that represent something. So typically a door is going to be shown as a line with an arc. And so if you were to look at this door that's out here, and I was to open it to 90 degrees, so fully opened, right? The door itself, when it's fully open, would be this line right here. If I taped a marker to the bottom edge of it as I opened it, it would draw a line on the floor, right? That's what the arcing line is. Okay? Make sense? All right, good. Here's another floor plan. I'm not positive which building this is. I know that whatever it is, it had a harem. So definitely not from around the United States. Okay? Definitely somewhere in the Middle East. It's got a ziggurat, so that tells me that it's from Mesopotamia, but I don't know. But this one is kind of showing a dense sort of floor plan with an overall kind of character, and it is showing a little bit of the site context around it. Okay? And you can see that there's dimensions that are sometimes written in here. There's the north arrow, right? And it's keeping the drawing square to the edges of the paper, and it's putting north as close to up as it can get it. Does that make sense? So, all right. So the next drawing that architects, so far we've covered site plans. Those do one set of things. Then we covered floor plans. They do a very different sort of job or task. And then finally we have this thing called an elevation. Not finally. The third thing is this thing called an elevation. And an elevation is a flattened view that's measurable of one of the sides of the building. Now, one thing that you have to bear in mind is that things might be coming forward and back, but they eventually all get flattened out. So like, for example, this is an eave overhang. See how it's sticking out past the wall? Can you guys see that? So you can see that in the 3D view, and this is kind of like, I took a flattened snapshot of it, but it's still like relating it in 3 dimensions. That's what the elevation will look like. Okay? And so if this building had another piece that was further back here, right, in the elevation it would be hard to tell what's in which plane. But you can measure them. Okay? And you can get accurate measurements off of it, where in 3 dimensions it might be harder. Okay? So this is just a simple elevation. Elevations that you may be looking at may be more complex. They may have ornamentation and tone value assigned to them. There may be shadows. Let me ask you all a quick question using your critical thinking functions. Do these shadows look correct to you? they're not, because this has lots of ins and out. And so the more in and out that it has, the more that the shadow would shift based on where the surface is. So this has been kind of rendered and doctored up to kind of illustrate the building. Okay? But it's still an elevation. It is flattened. Now we get to something that's very similar to a floor plan, and that is a section. Okay? So a sectional view is a vertical slice through a building showing the relationship of the pieces and spaces inside and the structural components and floors to each other. Okay? How many of you guys have ever seen a CAT scan? You guys have seen pictures of a CAT scan? Right? Well, a CAT scan is essentially a section through someone's head. Right? Or anybody ever gone to a fish market and they see a guy take a cleaver to a fish head and then you look at the fish and you see the nice little fillet, not the fillet, the nice little steak, like a nice piece of salmon, right? Well, that's a sectional view. And again, this is showing a three-dimensional sort of cutaway of this little house right here, the same house we've been looking at. That's what it looks like in 3 dimensions. And this is right here what it looks like as a building section. So it takes that and flattens it. Okay? This is a cross section. So we have a longitudinal section and a cross section, or sections going in different directions of a building. So notice that there's a little floor plan here, and that plan has these arrows that are designating what you're looking at. So this one, this symbol right here, is a section symbol showing that the slice is through the building this way. That's that view. And this one is showing a relationship to this view. Okay? Make sense? All right. This is another example of a section. This section is accurate in that it's been flattened, but then the designer, architect, draftsperson took some latitude with it, and they've kind of created this interior perspective from it. The section itself is not in perspective, but they've kind of added in what you might see if you cut it away. All right? This is one of the things I mentioned to you that I don't like about this presentation, and that's this idea of massing diagrams. Okay? So massing diagrams are typically going to show less detail and more of a block form. I've got better examples that I need to kind of incorporate into this PowerPoint. This is kind of a sequential development of a tower, okay, sort of showing how it might get molded down to its final form. Next we get to these things called paraline drawings. Paraline drawings are drawings that do not have a vanishing point. So you guys know that perspectives have a vanishing point, right? That the lines all point to that one direction. That line right there is parallel to that line, and that's why it's called a paraline drawing. It shows a three-dimensional view, okay, that in some cases is measurable. This particular one is what's called an exploded. It says isometric, but I doubt that it's an isometric. It's probably an axonometric. Isometric is a very specific thing. It has to use a certain angle this way and a certain angle this way. It has to be rotated a certain way. In either case, right there, we have this exploded paraline drawing. And again, in some cases, you can measure a distance and it will come up correct with the scale. Okay? Finally, we got bird's eye views, and so with drones nowadays, you guys know that you guys get some pretty crazy bird's eye view of stuff, right? I follow these people that are cruising on a sailboat around the world, and I love their drone images that they get, because it's like they fly up above the anchorage, you see the boats, and they literally fly over by, you know, where the village or something might be, and they're still sitting on their boat, and they're like looking at people having lunch or something. You know, all the way over on shore. So this is a bird's eye view of the exposition of 18-something or other, where the Eiffel Tower was built. Right there. See that little thing right there? I think it's that one. That little tiny building right there is a church that Gustav Eiffel designed. And it ended up It was taken apart. It was a modular building back in the 1800s. And it was taken apart and it was sold to a company called the Baleo Mining Company. And Baleo had mines in Africa and they had mines in the Americas. They were French. Okay? And what's an interesting story about that little church is that the Baleo Mining Company bought it for one of their towns, and they were intending to ship it right around the Cape of Africa. And a huge storm was brewing at that time, and I guess through telegraph, they diverted the ship and had the ship go instead to Baja California. And that little building that's there, that was exhibited next to the Eiffel Tower, is now in Santa Rosalia. You can drive to it in, I don't know, probably 10, 11, 12, about 15 hours. Trippy. Okay, and so we also talked about this idea of details and, you know, the sort of symbolism that could be in details. Well, detailed drawings are going to be little tiny parts of the building that get blown up to a larger scale, and they show more of the intricacies in the particular drawing. Okay? That makes sense? All right, so that is the end of my slideshow. Only one person slowly started to nod off. All right, now I need to stop it. And